There is a block kept on the ground, mass is 10 kilograms, and it is being pulled at an angle of 30 degrees from the horizontal as shown in the figure. Okay. The static friction coefficient is given to be 0.25. So the block just starts moving for what value of x? You have to tell, right? So what will happen? The maximum value of the static friction is equal to mu s, that is 0.25 here, times the normal force, right? So if I make a free body diagram of the block, this F, I'll take component, okay? This way, this is going to be F cos theta, and the vertical component is going to be F sin theta here, right? So I'll just make it here, F cos theta and F sin theta. I am taking the horizontal and vertical component of this force F here, right? And obviously the friction force will try to oppose the motion in this way. The maximum value is going to be this much, right? 0.25 times the normal force, right? What are all the other forces? Now the normal force is upwards and the weight mg is downwards, right? So mg is downwards, mg is equal to the mass is 10, mg is 100 newtons, right? And theta is 30 degree. So if I try to find out the normal force, okay, I'll balance out the forces in the vertical direction, right? That means F sin theta plus the normal force is balancing out the weight, okay, 100. So from here I can say the normal force is 100 minus F sin theta. Sin theta is sin 30, that is half. So I'll write F sin theta as F upon 2. So this is the normal force, right? So what can be the maximum friction force that can resist the movement, right? The friction force maximum value can be given by this mu s is 0.25, that is 1 by 4 only, times the normal force, that is 100 minus F upon 2. So this is the maximum friction force available, right? So the force that is trying to move the block, that is F cos theta, has to be minimum this much. It has to be minimum this much so that the movement can at least start. Okay. So in the limiting case, okay, when it just starts moving, I can say the friction force is maximum value, that is 1 by 4 times 100 minus F upon 2 is equal to F cos theta, right? The friction force is in this direction. F cos theta has to at least overcome this friction force, okay? So that starts moving. F cos theta, I can write cos 30 is root 3 by 2. So F root 3 upon 2, right? So I cancel this 2, this becomes 2 here. So I can say 100 minus F upon 2 is 2F root 3 here, right? So now I'll solve for F. You'll get, solving for F will give me 100 is equal to F 2 root 3 plus 1 by 2, right? So this is like F is equal to 200 upon 4 root 3 plus 1. Okay, root 3 is approximately 1.732, but you can take 1.7 also. So this will approximately come out to be 25 point something, right? So the option here I can find is 25.2, right? There is no other closer option to 25. So safely we can say option number 2 here is the correct option. Okay. So you can take the rough value of root 3 as 1.7, and then it will come approximately around 25.2. So you can safely choose option number 2 here as our answer. Okay. Thank you.